All right. It is my belief that I am live. I want to verify this. I should be able to see my own stream. We're going to be picking up where we left off today. Here we are. Yes, perfect. And I'll click into this. I should be able to. Yep, we're live. Very good. So, last time I implemented tokenization on an overlay network. We started by defining a little protocol for tokenization and how it might work. Then we coded up a little front end for actually issuing tokens, which I have here. Then we went and we built a topic manager for a topical UTXO set in an overlay responsible for tracking tokens through the system we created. And then we went and implemented a lookup service to track various UTXOs within that overlay, receive them, validate them, etc. At the end of the last stream, I said I published those two packages, the topic manager and the lookup service, on NPM, and I said I would deploy them so that we can use them on a Confederacy overlay network. And I've gone ahead and done that. You'll have to take my word for it, but they are deployed, and now we can interact with them. So in the last little video, in the last stream, I issued my issuance transaction, which had 1,033 tokens in it. And let me open up my MetaNet client here to show that. So got this mint 1,033 tokens, and that's a transaction ID. And I put that in a basket. Now the basket isn't going to be how we store things long term, but in this case, we'll be able to track tokens this way for now. So the code that we have from last time is you can enter this number of tokens you want to mint, and then you can basically mint them in a token minter, right? But we want now to actually be able to transfer these around. We want to send them to our friends, receive them, see how many we have, and we can go from there. That's kind of how tokens work, right? Somebody has them, somebody else wants some. So out of the ones that I have, I create a transaction and split them so I can give them some and take the rest back for myself. This code here, when the page loads, it's going to grab from my basket, right? All the tokens that are in my basket. And last time we talked about baskets a little bit and how maybe they're not the best approach for keeping track of tokens long term. But for the time being, it might make sense. Whether we have tokens ourselves or whether we receive them from somebody else, we want a way to register the transactions associated with the tokens that we've received or the tokens that we want to send, register those transactions on an overlay network so that when we later go to retrieve them, the overlay validates the tokens that exist, and we know that our tokens are valid. Also, a recipient can look up the UTXOs to ensure that according to the overlay, the tokens are received and valid. So I need a way to send a transaction, right? And right now what happens is, right, when we go to click that button for the mint, and this is for a mint, but it would be applicable to a receive, a send, a whatever as well. First we build our output script, right? Then we go ahead and actually create a transaction, and we put it into a basket, right? But that doesn't let anybody else know about it. A basket is private, right? When I take a transaction I made and put an output into a basket, that's like for me. So I can later, maybe like if I had a list of sticky notes on a sticky note app or something like that, I might have a basket where I would put my sticky notes. But when I want to send something to somebody else, I don't use a basket, right? So we're just logging this transaction right now, but we really need a way to let the overlay network know about sort of what is this transaction, and that way we can effectuate the transfer of tokens between two parties. Because the overlay network is really the thing that tracks the UTXOs and validates that they are in fact legitimate tokens that originate from the issuance transaction, right? Solve the back to Genesis problem, etc. And in our example here, we're just creating a transaction. We need to actually send it to the overlay network. So I have some code I'm going to go find for doing that, for notifying an overlay network about a Bitcoin transaction. So I think this is, let's see. I think this is in the KV store, actually. So KV store is a library. We're actually going to use KV store, I think, internally here in a second, but just bear with me, right? So there's a function in here, like find from overlay and also like submit to overlay. So I'm just going to copy both of these functions and we'll use both of them inside of our implementations. Because this is just useful code to have. So just going up here, right? Actually, you know, I'll make a utils folder, I think. No, I don't want to do that here. We'll move this code later because I want to put it into a class that's separate from the business logic, etc. But right now, right, we got a function that says find from overlay, and it takes something which we don't really care about, right? We want to actually we want to basically, I mean, I can copy this config object as well, just so that we have a config object. But the reality is, okay, those are our overlay protocol, right? I'm kind of getting ahead of myself. I'm copying too much code over, so I need to simplify this. Find from overlay, because I can add this stuff later. I'm going to delete this actually because I don't need it. Basically, we need a function that when we call it, it'll return. Deleting all this stuff that I don't need. So Confederacy host. I can set that as a constant up here. I'll just say const. And that's going to be, for our purposes, the overlay network node that I have here. So Confederacy host, right? And provider. And the provider I came up with, I named my provider TypePoint. So the lookup service is just going to be tie points lookup service, because I'm building these tie points, which are basically just tokens that we're building here, right? So this is a function that basically, when called, will look up all tie points from there, and then it'll return the JSON response for that. Okay, and then submit to overlay, you get a transaction, and so I'm just deleting this, and we're using this thing called authWrite to communicate to the overlay node and let the overlay sort of receive this transaction or facilitate lookup. All right, so we have these two functions, right? One of them takes a transaction and one of them looks everything up. So this code is going to look like it's compiling, but in reality at the top, we don't have authWrite yet. So I need to instantiate that. And if I actually go and say npm run lint standard -- fix, right, I can see in app.js, right, find from overlay is assigned to value but never used. authWrite is not defined, right? That's defined but never used. And then this one is not defined. So authWrite is not defined. So I need to use authWrite, which is a way to send data in an authenticated manner between parties, mutually authenticated. So both parties know without passwords who each other are and stuff like that. Because they use digital signatures using the MetaNet client. So authWrite's pretty cool. But I've just installed it, and I'll use it now. So I can just import authWrite. From authWrite.js. And we'll go over here, and we'll go ahead and refresh this page now. And of course, nothing's going to be different. Why? Well, because we're not using any of this stuff yet. But now we have these two functions. So find from overlay. Let's just call the function. I mean, right? That's like, so in this use effect, we're calling this to get things out of a basket. Let's also just call, from overlay, find from overlay, and we'll just console.log, right, from the overlay. Let's see what's from the overlay. So let's do a search and see whether there's anything currently in the overlay network, because we're telling it find all, right? And it's going to reload. So it's saying post lookup 400. And the error is this.storageengine.findAll is not a function. So that means maybe there's an error with our storage engine that we deployed previously. And if that's the case, then I may need to make some modifications to it. Lookup service, rather. So when I go look at the token lookup service, there was a query. And I had if find all is equal to true, then we call this.storageengine.findAll. Okay. And when I go look at the storage engine over here, I have a function called find all. So it's saying this dot storage engine dot find all is not a function. So this could be a number of different things. Let me do some looking at this to sort of. I'm going to do this for a second, just to have a look at some code that is sort of part of the deployment process of this. So just pardon me here for a second as I try to resolve this issue. Let's think here. I need to go to Confederacy. I need to go to. Just pardon me for 1 second. And all right, I've resolved the issue. I found a bug. I can show a little bit of this code, I suppose, to show what this bug was. So I'm instantiating my sort of lookup services here as part of the Confederacy implementation. And I used the wrong lookup service storage engine. I actually had that as KV store when it should have been tokens. So I'm just going to go ahead and I made this error yesterday. So I'm going to deploy that, and that should essentially resolve the issue. So when I went to look something up, I was using the wrong storage engine, and therefore it was unable to find anything in there. Now, obviously, because I just deployed this overlay network, and we can proceed while this is deploying in the background, because it's got to actually run a pipeline to deploy that to production, that change I just made. But as this happens, right, as I make changes here, as new transactions get submitted into the overlay, they're going to be tracked by the lookup service, and that's going to facilitate tokenization. However, since I just deployed this for the first time, and since I haven't actually run any transactions through this particular overlay network yet, there aren't any outputs in the overlay. And remember, in the previous one, we hard-coded the sort of TXID of the issuance transaction into the topic manager, so that the topic manager would kind of accept by default the output from the issuance transaction. One thing we're going to want to do is actually go ahead and well, let's check whether this is working now. But we're also going to, one thing we wanted to do, right, this isn't yet deployed, is we haven't submitted the actual transaction yet to the overlay network. The the token issuance transaction has not yet been submitted. So how about we add a button next to each of these called a submit button, and right on click equals and inside here you can submit to the overlay the transaction, which is called X, I believe. I think it's called X dot envelope. But we need to also include the envelopes in here, so. Okay, so this reloads. Cannot return envelope for already spent outputs. So spent so I'm trying to fetch the outputs here. And we're getting an error, which is cannot return envelope for already spent outputs. So checking the docs for the Babbage SDK, that function, the get transaction envelopes function, get transaction outputs rather. So include envelope, spendable. Spendable. Wait, spendable is true. It is able to be spent currently. So saving that code, that should resolve the error, okay? So, right, okay, now we can see two things. Number one, we have these buttons, right? You can actually submit a transaction and it would actually call that function to send the particular transaction to the overlay. And number two, you can see that in here now that we're actually successfully sending a search request to the lookup service on the overlay network and getting no results because there's nothing in the overlay yet. Now we can expand this and you can see the envelope is here. So we have this envelope which is actually the transaction itself. In this case we have a Merkle proof and a raw transaction structure. And for this one that's 101, 111 rather, let's go ahead and submit that transaction and see what happens. I'll click submit. And there wasn't any logging, but if I go to the network tab, it called the submit endpoint. And it's saying that it successfully admitted that into the successfully admitted output number 0 into the sort of topic, which actually I'm concerned about. It shouldn't do that because, well, let's see. Did it actually put that in there? So now we can see that from the overlay we have a transaction in the overlay now because I submitted that one. My expectation was that that particular one wouldn't work because there wasn't any tokens previously, and it's not the issuance, so it should have rejected it. But apparently it didn't. It admitted something, so that'll be interesting. Now I'll actually admit the one I wanted to admit, which is this one here. And I'm curious what's going to happen now. So it calls submit again, and once again it's got the type points topic, and it's saying that output number 0 was admitted into the type points topic. Okay, and now I'll hit submit a third time just to sanity check this, and this time there should be some type of an error. Or right, it's saying that no topics admitted it because that's already been admitted. So now there's going to be two outputs in the overlay, when I refresh this page, right, from the overlay we got two outputs. I didn't want this 111 to be in here, so it's a good thing I tried to submit it. And the reason why is because it's not the issuance, and so therefore it shouldn't have been accepted. Let's go ahead and look at some of the code to see why that might have been accepted. Why did the issuance output, or why did a non-issuance output that didn't have any previous UTXOs get accepted into this overlay? So we make sure the transaction has inputs and outputs. If the TXID is the issuance TXID, then we return, right? So maybe both of these are undefined. That's like what I could think of, right? If both are undefined, then of course it would be admitted. So I instantiated, right, issuance TXID. This dot issuance TXID was equal to that, and I was checking, right, whether parsed transaction is equal to, right, parsed transaction.txid is equal to, and I was returning this. So that could be one option, right? Maybe when that was sent through, both the issuance TXID and the parsed transaction TXID are undefined somehow. If that's the case, then, well, it makes sense. Now, right, because we're trying to, we have this, and this only gets incremented when there's previous UTXOs. So if this is 0, max tokens is 0, we go and add the ones from the outputs, and if anything is greater than 0, right, then an error would be thrown. So my inclination is that when this got through here, somehow parsed transaction.txid is undefined, and also this .issuance TXID is undefined. Let me pull up that code again that I was just looking at before to make sure everything is being configured properly. So just bear with me for 1 second as I do that. And so I'm configuring the, I'll show the bug once again and why I think this happened. So when I went to instantiate this, once again, I just used the KV store one instead of the type points one. So I was using the wrong topic manager, I guess. So I did make some bugs in the implementation of the, I believe this is called token manager. And yeah, so let me get this deployed with this update. I used the wrong topic manager, and therefore, of course, the acceptance criteria is going to be wrong, because those are valid push drop outputs, even though they're not necessarily valid token manager outputs. So I'm going to do a couple things. First thing I'll do is deploy this. And then after this is deployed, okay, so that code is committed. After that's been deployed, I need to also probably remove, well, I can either remove those from the topic manager, because I kind of have that, you know, in the topic manager now, or in that topic. I think yeah, that's what I'm going to do. So I'm going to go into the database and I'm going to actually delete the ones that should not have been admitted into that topic. And from that point, it should be valid. So let me just open up my I'm just removing manually out of the database for the sort of overlay network node the transactions that were inserted inadvertently, so that when we have the overlay network, we have a set of UTXOs that are actually compliant with the rules we're enforcing by the correct code. It was the case of me using the wrong code, essentially. So what I've done here is I've just removed the relevant transactions from the database so that when we go and use this again in the future, it will not have issues. So I've made those changes. I've deployed the new version. I'm going to just check and verify that the new version is successfully deployed with the correct code. So just give me a moment to do that. And it looks like the new code has been successfully deployed. So we're back in business. Okay, so let's try this again. Right now when I refresh due to the changes I've just made to the database, I can see from the overlay there are no tokens anymore. And now let's go ahead and try to submit this transaction to the overlay that just, you know, that mints 111 tokens but is not the issuance transaction. And let's see what happens. So I go to the network tab called submit, and it indicates that no topics have accepted, right? So when I went to send this, I said, I want this to go into the type points topic. But in the response, it was not admitted, right? It was not admitted into the type points topic because it did not constitute a valid spend of any valid type points since it didn't originate from the issuance transaction. Now let's go ahead and refresh this and verify that when I see from the overlay, that transaction is not there. Now let's actually add the correct transaction and see what happens. So I just hit submit on the issuance transaction. And this one, it also looks like it's it's not it's not in here. So we'll have to figure out why that is. So the issuance transaction was 1,033 Satoshis, and I went to submit it. I'll do it once more. And I can see that there is no issuance transaction being admitted either. So to figure out why that is, I'm going to, yeah, I can see from the overlay now there's nothing. Right now it's not admitting the UTXOs. So I did not manage to get my issuance UTXO admitted like I intended. So that's because the overlay is not allowing it to happen. And I need to check the logs to see maybe there was an issue or something with the code, and if I find something relevant in the logs, I will put it up on screen. So let me go ahead and just access the logs here for my production overlay network node that tracks this stuff. So give me a moment to do that. Okay. Just reviewing some logs here. I don't see any logs that seem relevant to this context. So therefore, I think I need to add more logging to the system so that when I go to deploy this the next time and try it, right, yeah, I see no output, and I really don't suspect I would because I didn't add very much logging previously. Okay, so I'll put this back up. I'll add a bit of logging here to the relevant context. So the topic manager is here, and if an error gets thrown at this level, it'll be caught by this, and it'll simply return. I'm not logging anything, so let's start by adding some error logging there, so that if any of these things throw an error of any kind, that error will be logged. Okay. This time I'm going to log as well both of these so I want to know in the log whether that is equal to that. And if so, say admitting issuance TXID, okay? And I'll then go ahead and log the max tokens. Okay, and then we'll go ahead and add each of those. And that way we can see them. And that should be enough logging. Now we can actually get a picture for what's going on as this happens. So what I'm going to do is publish a new version of the topic manager with logging. It's going to be .1.2, and I'll go ahead and incorporate that new version into the deployed code, and then we'll try again. So I'm just deploying the new topic manager on the overlay network node. And I'll go ahead and wait for that to be deployed. Meanwhile, I'm going to access the logs once again. So that we can see this working. All right, now I'm just waiting for the deployment process to complete. And I suppose one thing I want to do is sort of separate these two. Let's do that. Okay, perfect. All right, so I've just kind of moved my browser around a little bit so that I can still access things externally. So I just want to wait for this deployment process to continue and complete. And once that happens, we'll be in a position to admit, hopefully, or we'll be in a position to see what the problem is with admitting the issuance TXID and the issuance transaction, the output into the overlay. Nearly finished with deployment. And once that deployment process finishes, we'll be able to proceed here. All right, the deployment process has completed. I'll now be able to access the logs more effectively now that I've added that logging when I submit these. So I'll submit the one that I expect should work. I just click submit, go to the network tab, I'll go here. It indicates no topics have been, no topics have emitted this, which is not what I want. Now I'm going to access the logs, and we'll see if there's anything meaningful in the logs. So I see an incoming call to submit, and no relevant logs. So that's odd. I don't actually see any logs for the transaction at all that I'm trying to submit. And I think in all cases here I've been in a position to be able to see those. So I'm not exactly sure as to why that would be the case. I'm going to pull up the internal code here for the overlay server to see whether there might be anything I can spot here. The transaction has been admitted there. I think the only thing I can think to do is create a new transaction. So I'm just going to create another one of these and then try to submit that, I suppose, because perhaps there's a duplication of some kind between what has been created and what is already there, and that might give me some insight. So I see this one, which has never been submitted to the overlay before, even before I cleared the database. And I'll just kind of submit this one. I expect it to be rejected. And yet, okay, that's interesting. And it indicates here that, right, okay. I'm going to access the logs now because I see that there's an empty array versus it not being present at all. So that might tell me some information that I hadn't learned before. So, okay. I see some errors. I'm going to copy from the logs It's telling me I cannot read properties of undefined, reading toString in push_drop.decode. So, and then it's cannot read property field. So let me review some code here. Upon reading through some code, I'm trying to debug some issues related to the logs that have been brought up. I think these are as expected. Right. Okay, so I've concluded that I did not properly empty the database when I did this the last time. And therefore those new attempts at submitting outputs were never actually successful. Because it never, it still thought that transactions yes. I'm just figuring out. Pardon me for 1 second here. All right. I believe I've resolved the issue that I've been facing this entire time, which was related to the database. There's a duplication checking mechanism in the overlay network node, and while I had removed the data from the database, I never removed the transaction IDs from the transaction duplicate checking mechanism, and therefore, when I went to submit those transactions again, they were never admitted into they were never even presented to the topic manager, and therefore there was no logs, and there was also no, it wasn't admitting them either. So because of the removal, I believe I've now removed them from the duplicate checking mechanism as well as from the lookup service and the rest of the database for the overlay node, and therefore I should be in a position to properly run these transactions again. Let's go ahead and refresh and kind of give a start over here. So the expected behavior is that when I go ahead and try to submit this, I'll submit the first one. Okay, and I should see that this is not admitted into the topic. So I see that typepoint's topic with an empty array means that it tried to get it into there, but it was never accepted. That's correct. Now let's go ahead and try to admit the issuance transaction. And this time you can see that the output is successfully admitted from the issuance transaction. Finally, let's try to admit this third transaction. And this time it's not even admitting, and this is due to the duplication mechanism that I was referring to earlier, but that transaction wouldn't have been admitted anyways. So you can see that the issuance transaction has actually been admitted this time, and that is now the only member of this topical overlay. So I can see that there's one sort of output in the overlay now, whereas before there wasn't. And that's significant because it means that we've got something in the overlay. And so if I try to spend something that didn't come from that, such as by submitting any of these other transactions or minting other tokens, the overlay is going to refuse to accept anything except for something derived from the issuance transaction, and therefore the tokens that are descendants of the issuance transaction are valid, whereas any other tokens are not valid. So that's kind of the overlay in operation. Now we have an idea of how that's going to work, and we want to be able to create transaction outputs. We want to be able to spend these tokens, because I have the tokens in this overlay that are part of, part of the what comes back, but I need a way to redeem them. I need a way to actually spend them and use them again. So what I can do is create another transaction. And before we do that, I'd like to have a way to receive these tokens from by a third party as well. So let's go ahead and add a way to let's add a way to receive tokens from a third party. And how might we do that, right? If I come online and I want to know whether I've got new tokens, I want to know what my balance is, something like that, how can I do that? When you receive tokens, you receive them from somewhere, and that somewhere is one of your peers, right? Someone sent you these tokens over some communications channel. So we have to establish a communications channel for peers when they want to send each other tokens, right? If I want to send a token to a friend, how do I reach that friend? How does that friend receive the data from me needed to understand that they have received a token? And then, of course, we can get into what steps does that friend take in order to validate the token that has been received to effectuate the transfer and whatnot. But really, we need a way to communicate with one another. And that's what PeerServe is. So PeerServe is a way to send messages between parties, and then Tokenator is a system to actually implement the front-end side of interfacing with a PeerServe instance. So let's go ahead and start writing some code, though, so that we can understand some of these things and how they actually work. what we want to do is, we're now using these functions, right? The submit function and whatnot. But we want to see something more like a send and receive and balance idea. Let's start by looking at Tokenator, which is some code, and see what we can't do with it in terms of using it to send and receive tokens between parties. So Tokenator is a versatile and powerful tool that allows developers to easily create and transfer tokens peer-to-peer on the metanet, right? This is a base class. So here's example usage, Tokenator. You got John Smith. There's his identity key. And then you say new Tokenator, and you give a peer serve host. And you say send message, and you give the recipient, the message box, and the body. Okay. So we need a way to send messages which contain tokens to our friends, and then as our friends, to be able to see these incoming messages and then process the tokens and store them in such a way that, right, I can access them later. So let's go ahead and try to use Tokenator to send a message from one user to another, and then we'll receive that message back. For simplicity, we'll send the message to ourselves at the beginning, and then we'll add a token to it. And that way we can exchange the tokens peer-to-peer. And then we'll add support for other people. And then we'll have somebody help test it, hopefully. So let's go to the front end. Let's install Tokenator. And let's import it. So you got send message, list messages, and acknowledge message. So you can, right, send a message with those parameters. You got the message recipient, the message box, and the body. You got the ability to list messages in a message box, and you got the ability to acknowledge message by providing the message ID. Okay. And so let's decide on a message box and a peer serve host. Is it peer serve host with a lowercase s or an uppercase s? I never remember. Peer serve host, capital S. Peer serve host. And that's going to be peer serve Babbage system. So peer serve is just a way to serve messages to your peers. And then let's just use typepoints box as a way to send around these tokens at the beginning. And we're going to clean this code up a lot. We're going to clean up these concepts a lot too as we move along here. But the idea here is that we just need to get something going so that we can iterate. So the message box is here. Let's go ahead and have a way to send a message to somebody, right? Namely ourselves. So let's make a function inside of this component called send. And in this function, which is going to be asynchronous, we're going to do what it says in the README. So we got John Smith. Well, actually, let's grab our own identity key. Own key, and that's going to be get public key. And then get public key comes from the Babbage SDK. So basically, there's our own key, okay? And then, now that we have that, we have tokenator. We build a new tokenator, we do this, and then we actually receive the message back. So let's just copy this code directly from the README. So tokenator, pure serve host comes from constants. And we're just going to send a message. Recipient is own key. Message box is going to be as defined. And the body is, this is an example message, okay? So John can now list the messages. Messages tokenator list message, right? Message box as defined. And let's just go ahead and console.log all messages. So what should happen in this case is that when we call this send, right, and then we acknowledge the messages, which kind of remove them from the server. So when we call this send function, and we'll hook this up to a button so we can call it easily. Let's just add a button on click. Right, now we're sending a message, and you click on the send button. The idea is should be able to see this working. So it's requesting that authRight be used to send messages to the counterparty. And now you can see that we have this message which has a body. This is an example message. Created at, you got a message ID, sender, okay? And now you have like peer-to-peer message exchange between parties. That's what PeerServe does in Tokenator. But we want the ability to do sending tokens, right? How do we actually send a token to a party? And that's where, you know, the next step comes in. So I need a way to basically receive and process incoming tokens, and it's easier to receive and process. We need that code first because it makes things make a lot more sense. Right now when the page loads, we're doing this stuff with the use effect and the lookup service and whatever else, right? But that's not really what we want to be doing. what we want to be doing is checking to see if I have any new tokens, right? So this basket stuff, we talked about baskets before. The reason why I kept that token in a basket before is so that when I issued it, right, it would get under the overlay. But now it's in the overlay, so I don't really care. I just need to make sure that actually let's think here. I have this send function, and I want to send a token. And we have this variable up here called my tokens. And the second one is in the overlay. My token sub 1 is the one that we know is in the overlay because we put it there and it worked. So if I wanted to send my token sub 1, right, to a recipient and have the recipient receive and process that token, and I'm going to delete this for a reason. You'll see why. So we got the send function, and it's like, okay, who are we sending to? In this case, it's just ourselves. Make a new tokenator, and we're sending to a message box this message. What is the message going to be? Well, it's going to be a JSON object, and one of the things in there is going to be, we know my token sub 1 is actually a token that came from the overlay that we created. So I'm sending this message out, right? I'm sending this token. So we know my token sub 1 is a valid member of the overlay. Okay, let's just think about this. So I'm saving this. My token sub 1 exists. Go ahead and hit the send button. I'm going to go to the network tab, make sure it got sent, right? Send message, right? And the payload was message. The body contained, all this stuff that is related to my token sub 1. Okay. Now that's kind of in the peer serve, right? In the use effect, so now we can pretend to be the recipient. It's like, okay, I just received a token. How do I know that? Obviously, I need to see my messages. So in the use effect, when the page loads, I need to be able to my incoming messages is and the tokenator, actually, I'm going to construct up at the top, just so that it's everywhere. Okay. So tokenator we get to use everywhere because it's up at the top. So tokenator's there. All right. The send function kind of sends off this thing that we hard coded for now, right? And then when the page loads, we're saying my incoming messages is this value here, right? And we're also doing this stuff with baskets, which eventually we're going to get rid of, but we'll do that in a second. Okay, let's just log my incoming messages. So when the page loads, I should see if I have any new tokens that I'm looking to receive. Okay, and it looks like there's there's one here, which I have the message ID, I have the body. Okay. So for each message that is incoming, we need to validate and save the token. How does that work? Well, for message of my incoming messages, go ahead and, well, we have message.body. And we have token. So that's going to be basically when you receive a token from somebody, what are the next things to do with it? Verify the token is on the overlay. Verify the token is owned by me. Save the token in my list of tokens. Acknowledge receipt of the token. So when I receive a token from somebody, these are the things I need to do. Actually, it makes sense that I receive the token, I make sure it's mine, and then I check whether the network recognizes it. If someone says they sent me a token that's not for me, I don't want to do anything. So how do I do that? Well, how do I know the public key of a token that I received? Or I can decode it. So I can say push_drop.decode. We have push_drop in this context. Decoded token and we need to verify that it's me. So when the token was created, we used a particular protocol ID. In this case, the tokens protocol with key ID 1. So I can verify the derived child public key. My key is that key. And if my key is going to be the locking public key of the token, then, well, we know we're good. And if it's not, then we're going to move on to the next one. Receive token not belonging to me if the keys don't match. All right. So, cannot read properties of undefined, reading output script. Let's see what happened. That's going to be in 95. Oh, token. So token is undefined. So parsed body is that. So I need to see what parsed body is to see if how I can access this data that I need. Parsed body is a string. Am I calling no, that's a string. What? So I called JSON.parse on the message body, and then do I need a JSON.parse? JSON.parse? That's odd. Okay, well, for some reason that worked. So this is a token that I received. JSON.parse for some reason. I wonder it's because I think when I sent the message I said JSON.stringify. I probably didn't need to do that or something. I guess I'll just leave it for now. That's odd though. I'll figure that out later. So I'm parsing the message body, and then I'm getting the token, and then I'm checking this, and I don't see that it doesn't belong to me. That means that this token belongs to me, just to make sure. So when the person receives a token, this token belongs to me. Okay? So that makes sense. We need to verify that the token is actually in the overlay. Okay, so we know the TXID. We know that token.txid and token.vout are here. And we have a thing for finding from the overlay, and that can take in txid and vout as well. So instead of saying find all here, right, txid and vout can be passed in. Let's get rid of this query from, outside this context. So we got from the basket, we're not dealing with that anymore. Okay. And then from the overlay, we're not dealing with that anymore. Basically, can I verify that this is a token that's in the overlay? So verified equals find from overlay. And I can just pass in token because token has txid and vout on it. So if I see anything in the verified array, I know that this token is part of the overlay. Looks like. Oh goodness. That is from old code from okay, let's think here. Find from overlay, I got async txid and vout, and the query contains txid and vout. And if I go and look at the lookup service, I can point you at why that error is. Right? It's obviously the right, this code down here. It's talking about song IDs because this is where it was originally copied. You know, this is a copy of a copy. It's saying query.findAll is true, or query.txid. So if query.txid and query.vout. Now, vout is a 0. It's a number. Okay. In this case, if it's 0, it's okay. So what it should be is if type of txid is not undefined and type of vout is not undefined, then do that. Because what's happening here is I'm passing in, when I go look at this, when I go look in the network tab, I'm passing in my payload here, my query. Vout is 0. So that's a 0. It's a falsy value. And therefore this is not being executed, but instead it's going to check for this. That's not there anymore, so it's going to go here. Okay, so I needed to make that update, and I'll push this. So that's a bug that we've just fixed. And then this here, right? This is just a query parameters must include a valid, must include essentially either a txid plus vout or find all equals true. I think that's good. Okay, let's deploy the new lookup service. Okay. Falsy vout, right? And the version of this is 0.1.1. That gets published onto npm. And I'm then going to deploy the new version of that onto the overlay node itself. So I'm installing the new version of the lookup service. With that fix. And then with this having been deployed, I should be in a position to query from the lookup service by txid and vout within this context. So I'll give that a few minutes to deploy. But essentially, what's happening here is that we're now passing in txid and vout here, and it's going to take those and use that to query. So we're checking whether the UTXO is on the overlay. So if verify.length is equal to 0, or is less than 1, right? So if there's no UTXO on the overlay, then we're going to continue. So we'll say token is for me, but not on the overlay. Otherwise, token is on the overlay. Okay, so we've just now confirmed that when we receive a new token, number one, it is for me, and number two, it is on the overlay. And if we know that information, that's useful. It means I have a new valid token. Well, do I know it's new yet? I should make sure somebody isn't sending me a token that I already have. But of course, that means I need a way to store my tokens, right? I just received a token. What do I do with it? How do I know what are my tokens and what are not my tokens? I mean, how do I store anything that I receive? And that's where users have the ability to sort of keep data, right? Users have the ability to keep tokens, and they can do so using a thing called KV store, key value storage, meaning they can store things that they have, such as their tokens. So save the token in my list of tokens now that I know it's mine. To do that, we need KV store, so we can have a list of tokens that that are mine. So I can say npmi babbage kv store. Okay, and when you have kv store, you have get and set. You can get keys and set keys in kv store. Get and set babbage kv store, right? And by the way, all this code that's really messy, we're going to clean it up over time, and we're going to move it to its own package. And then it'll be a package for general purpose management of tokens, etc. That'll be really cool. So if you're wondering why all this code is really dirty right now and whatever, it'll get better. So, okay, first I should make sure the token is not already in my list of tokens. So let's go ahead and say something like my tokens equals get my tokens, and the default value, if it's not there, is going to be some undefined, let's think, an empty array. Okay, I have an array of things, and so I'm getting it, and if I don't have it, then it's empty array. Okay. So JSON.parse. Now I got if my tokens, let's think. So I want to make sure the TXID and VOUT are not already there. Okay. If my tokens dot sum t, where t.txid is equal to token.txid, and t.vout is equal to token.vout, then continue. I already have this token. All right. So at this point, we know do not have this token yet. Right? So we know that at this point, we're looking at a token that is new to us. It's not in the My Tokens thing in KeyVStore. Now we need to save it. How do you do that? Well, myTokens.push token await set myTokens JSON.stringify myTokens. Now it's saved. What else do you have to do after that? Well, save token properly. Okay. So when I save this file and open my browser, a lot of things are going to happen because of all this code we wrote, right? It's going to automatically run this because the page loads automatically, right, when you save. And then it's going to go and get a list of all my messages from my message box. It's going to parse each of the messages. It's going to find a token, because remember we sent that token up here earlier with this code. It's then going to decode the token. It's going to grab my key and make sure that the token is from me. It's then going to verify that the token is in the overlay, and if that code that we just pushed to production is working for the overlay network, then that's going to work, and it's going to confirm that the token is in the overlay. Then it's going to use KVStore to check, and it's not going to see anything in here. So then it's going to not run this. It's going to get down here, and then it's going to actually add the token to the list of my tokens, set that in the overlay, and then log this. And then we're not going to acknowledge the message yet because I want to see if any of this works. And also, later I want to see whether it sees this in the my tokens key and then doesn't do this and says, well, yeah, but this isn't a new token, right? So let's go ahead and save this. So code saves, browser should reload, we'll check the console. Token is in the overlay. Do not have this token yet. Now it's asking me to create a new KVStore key called my tokens. And if we've done everything properly, the token is now saved. Okay, good. So now we've actually saved a token. We've received a token into our account from the sender, who is also us in this case, and saved it. And that is a success. Now, if I refresh this page again, it should not say saved token properly. It should say, oh, I already know about that one. We don't need to save that one again. So let's see how that works. I refresh this page. It's saying, yep, token is in the overlay. Already have this token. All right, very cool. That was a complete success. That means that we can now receive tokens, but we won't receive them twice if we already have them. And we only receive tokens that are ours, and only if the overlay recognizes them as valid tokens. That means that we're coming along with our implementation for general purpose tokenization, which is pretty cool. So we say continue here, right? We're in this loop of all the messages and whatnot, but we kind of know at this point that actually we want to acknowledge all these messages. And the reason why is because this loop goes through and every time, right, once you continue, you're done with this message. You don't need to do anything else with this message. So at the end here, right, we have these opportunities to continue, but this should come out of this loop, this comment, And then it should come down here, and we should acknowledge the message, right? So let's go ahead and now this code isn't the most optimal. For example, the myTokens.push and this whole idea up here, this should probably be done outside the loop as well. Why do we need to continually set new things in the loop and get them in a loop when we can get them like before the loop? So it's like, okay, if there are new messages that need processing, even if we don't have new messages that need processing, right? So it's like my tokens, we fetch that, okay? We also have a state variable called my tokens, which is kind of confusing. So we'll go ahead and, well, it's going to be one and the same, as you'll find out. We got my tokens here. We're doing some processing on that. Then my tokens.push, and then we go here and so now we basically should acknowledge receipt of all messages, and then we should do this. Well, first we should save we should save these first. Sorry to pan around so much. Save new state of my tokens if necessary. So set my tokens, JSON string my tokens, right? We could say if we need a flag. We need a flag that says basically, has this been updated, right? So say, did tokens change false? And then if you ever do this, if my tokens.push, then did tokens change is true. Okay, and then if did tokens change, right, then we'll go ahead and do that. Then we acknowledge receipt of all messages. So that's going to be coming from my incoming messages. And then we set my tokens to my tokens. Let's go back to the Tokenator README, which has some code for acknowledging all messages. So Tokenator.acknowledge messages and message IDs. This is just going to be my incoming messages.map. And now that code's a little bit more optimal. This is the code that happens when you want to check whether you have any new tokens. And by the end, you have the my tokens variable, which is always going to be your current set of tokens, right? So before we were getting that from the basket, and we had those weird ones that we kind of don't care about. When I save this and load this page again, okay, already have this token. We see that for the last time. We see the my tokens, and this is actually the token that we have. And we got rid of those other ones that we didn't have because they weren't technically in the overlay. Now, if I refresh this the last time, and the next time, we shouldn't see this whole token is on the overlay because we're not doing any processing anymore. We've already acknowledged receipt of that token. So we should just have the my tokens variable now. Let's see what happens here. Oh, okay. So if there's no messages, right? If so, we only acknowledge the messages if my incoming messages dot length is non-zero. And pardon me, somebody's calling me. It's probably a robocall. Who is this? Hello? Hello? All right. Well. Okay, so that was a robocall. Nothing useful there. Let's go ahead and proceed. So we were saying that if my incoming tokens dot length is anything above 0, right? If it's not equal to 0, in fact, then we'll acknowledge. But otherwise we don't need to, because there's nothing to acknowledge. So now we can see that we have one token. We can see that the token is here, and we've successfully been able to receive and validate it. So now I have a token, right? And that's how that works. Now, if I want to send a token to somebody, we kind of hacked together that code last time, so we could kind of have this that one we issued in the system. But let's go ahead and make it a little better now. So the code for sending tokens. How does that work? If I want to send a token to somebody, how do I do that? Because now I can receive tokens. Okay. So we already have some of this code, right? JSON dot stringify this value here. It's like that's what they want to receive, right? So here's the person, but it's not my token sub 1. Like, that doesn't even exist anymore. We only have 0. And by the way, we need to create a new transaction, right? So when you send something to somebody, you need an amount too, right? And let's think of this UI. Like, this UI really isn't the best. We have this token minter, and we can mint things, but we're kind of beyond that point, right? Like, that's might be useful at some point for something like when you get started with issuing new tokens, right? But when you actually want to send, let's make this UI just slightly better. I think is kind of what it comes down to. So we have this token minter, but then we have this button for that, and then we need a h1 again, and we'll say token sender. This is how you send tokens. I mean, not that intuitive, but and I have the my tokens. So I'm gonna get rid of this. Well, let's think. Yeah, this was temporary, right? This my tokens thing. The submit, at least part of it was temporary, and probably the rest of it too. But this is a very simple UI right now. We have the token sender. So when I send a token, I need to enter the amount value equals send amount on change set send amount e.target.value. Okay. Send amount set send amount. Right. Let's go ahead and set that to some number. So and 10 is a fine number. Okay. So now if I look at the UI, I got like a token minter and I got a token sender. I can enter the amount and I can enter the amount. Now the minter doesn't really work unless you're wanting to mint a new, thing, but the token sender, once you got your thing plugged in, should work fine. But right now it doesn't, so let's change that. What else do you need when you're sending a token? I mean, you need the identity key. So you got the recipient and set recipient. Let's go ahead and when the page loads, last thing I want to do is actually let's be a little bit, let's be slightly set identity key, await get public key, identity key true. And let's actually grab an identity key state variable as well. And the reason why we're doing this, you'll see in a second. Okay, is that now when the page loads, I can render my identity key. So I'll say H3, well, let's say P B identity key. So now, in theory, I should be able to see my identity key when the page loads. That's the idea anyways. So it should load, right? There's my identity key, okay? And when I want to send a token to somebody, I have that recipient, and I want to populate that as well. So now we're getting somewhere. So I want to send an amount to recipient set the recipient so now I got the amount and the recipient and my own identity key. And actually, I can make this a little faster by running some of this in parallel. So that has to run as its own thing. But I can make this page slightly faster by just saying something like that. Okay. That's the recipient. So this is just going to be recipient now. When I want to send something to somebody, right? Send a token. It'll be to the recipient. And the message box and the body will be something that we don't actually want to do right now. We'll do it in a second. So Let's think. I'll just I don't want to actually do this, so I need to think of actually the correct way of creating this information. So when you send a token, what are the steps, right? To send a token, gather your own tokens. Make sure the amount is less than, rather, is not more than what you have. Create redeem scripts for your tokens. Create outputs for the recipient and your own change. Create the transaction. Send the transaction to the overlay. Send the transaction to the recipient. Update your own tokens to be the new outputs. Okay? So if we followed all these steps, we'd be able to send a token from Alice to Bob. Right? I mean, that makes sense, right? These are how you might send a token, I might think. So this part goes where? Where does this part go? This is send the token to the recipient, right? So you got a couple things going on here. You got a lot going on in this function. We need to write this function to actually send the tokens to the recipient. That's not an easy process. But once it's written once, I'll make this code look a little nicer and write some tests and write some specs and write some docs and stuff like that, and then we'll eventually get it out to the entire world. That'll be kind of cool. And it'll improve over time, of course. But let's think. So I want to think about this here, which is when I have a token, first we should gather our own tokens. Well, we have the myTokens variable, so that doesn't really apply. Okay, that's done. Make sure the amount is more than what you have. How do we know the amount, right? So my amount. I mean, maybe that's an important thing to compute just ahead of time, like in a balance. Do I want to see my balance on the screen? I mean, maybe I do. I don't know. My balance. By default, it is 0. And can I compute that in this function? I probably can. Set my tokens, right? But I can also say let balance equals 0 for const x of my tokens t decode script t.output script field format UTF-8. It's going to be balance plus equal t dot x rather t dot field sub 0, and it's a number. Okay, so my balance is going to be that. And let's put that up on the screen next to the identity key, because you know what, why not? P B whoops balance and that's going to be my balance. Let's see if that works. I should have 1033 in my balance when it loads. There it is. So now I got my identity key. If I want to receive, I can send to myself too. And I want to just run a test of this function to make sure it's going to work. So it's going to be something like window.alert sending send amount to, and then I want to return. Okay, so there's the, okay, if send amount is greater than my balance window.alert, let's see, no, not sufficient tokens. Not even going to try. I mean, they could try, but they'd get rejected by the overlay network because of the code that I wrote on the last stream. So, we'll refresh this here. The balance and the, so this is 0 and then it loads, when this loads, essentially. If I say I want to send 23 tokens to that person, whoever they are, gosh, I don't know, it would say sending 23 to that, and then I would say yes. That means that, okay, I have tested my function. That's what I wanted. I'll get rid of the return statement now. All right, it'll say that at the beginning each time. Create redeem scripts for your tokens. Okay. So push drop.redeem allows you to spend UTXOs that you've previously that you own. Right? Pardon me. I'll grab some water. I'll be right back. All right. So Push-drop.redeem allows you to unlock UTXOs that you own, push-drop tokens, in this case, and do things with them. So let's go ahead and mess around with that a little bit. I want to see an example of a push-drop.redeem. Gosh, I'm thinking of a few places around my code that I use it. I think KV store is once again a relevant place to look. So let's go ahead and in the remove function, there's also one in the other, but so you get the token and you redeem. And then you put an input and you do the action, and that's how that works. So let's go ahead and play around with this. Right, got some code here. Create redeem scripts for your tokens. All right, so let's just redeem all of our tokens all the time, because that's it's not the best idea, but it will work. And later we can go basically for each until we're greater than the amount that we need for this particular transaction, and do input selection and everything else, and we'll build that. At some point, like, you're gonna have Benford's law but for tokens, which is really cool. Right now we have that for Satoshis, and Babbage manages that internally, meta client, etc. But we're building some low-level tools here for tokenization, and we'll be able to actually reuse a lot of the code. Anyways, I'm getting sidetracked as I think of the implications of what we're building here. We need a variable to hold the inputs, basically. Okay, and then we're going to do this each time. So, right. There's our inputs. For each token in the my tokens sort of list. Okay. We're going to get the unlocking script. And how you do that is you say T. Whoops, I did that too many times. So you get the output script and the Satoshis and everything, and you say the protocol ID, in this case, is just tokens, right? So you haven't set one really, and that'll be later, right? And the counterparty, in this case, there is no counterparty. I don't believe. I'm trying to think. Would there be a counterparty ever? When I redeem a token, was it created? Well, yes, it could be. The counterparty is the sender of the token. So I'm going to say T dot sender. Or self if T dot sender doesn't exist. So either it's your own token, or you got it from yourself, or you got it from somebody else, and either way the counterparty is self in that case. Okay, I just thought through some. Okay, so we got the unlocking script for this token that we're dealing with, and then when you get the unlocking script, essentially, if the inputs sub t.txid is already a thing, if the inputs aren't a thing, meaning if this transaction doesn't already have something on it, then you want to set it equal to something like this. So inputs equal ... right? That'll just be t. And that is an object. Okay. So if the inputs don't exist, and you do that. If the inputs do exist, then you actually just need to push the new unlocking script in vout onto the transaction that already exists. So in that case, you'd say else, and it would be input sub x.txid dot outputs.redeem.push, and you're just saying, this transaction input is already, from this transaction, we're just adding another output that we'd like to unlock. So the end result here is that you have this inputs variable, which is all of your inputs across all of your different tokens. And that's it. I mean, we've now derived, we've done what this comment says, which is to compute redeem scripts for your tokens. Okay, that's done. What is next? Well, we need to compute the output scripts for the person who is receiving the token, as well as for ourselves. Okay, so and this code, by the way, create the transaction belongs down here, and also it's the inputs are just going to be like that. That's already done. All right. So that's where that's going to go, and also there's going to be outputs, which we're going to add now. So let's first create the output for the person that we're sending the token to, right? So we want to send this token to somebody. How do you do this? Well, we have some code up here already for that, which is this. So when you create, right, a token, well, output script is push_drop.create, and the amount is going to be a stringified version of the amount that we want to send, which is send amount. Okay. Protocol ID, the ID, and the counterparty is the sender. That's important. The recipient rather. Counterparty is the person who is receiving the tokens. And that's important because they need to be able to unlock. So it's their public key that is being used to sort of assign the new tokens. So we're assigning to this recipient this ability to spend these tokens. And that is the send amount. All right. So that's the output script. So we'll say outputs.push. And we need to send, right? You know, that type of thing onto there. And we don't need this right now because we already have one down there. It's going to be send send amount tokens. All right, so the output is added, right? And then if the send amount, so if my balance minus send amount is greater than 0, so if there's something left in my balance after I sent these tokens, we need change, don't we? It's going to be, I don't want to call that token script, I want to call that recipient script. And in the case that I need to send some back to myself, let's go ahead and add our change to the token. So it's going to be something like change script. My balance minus send amount. Okay. And the counterparty for the change script is always self, because it's me who is receiving the change. So we'll push change script onto there as well. Satoshi amount's 1,000. You know, it doesn't matter because the tokens that we're sending are you know, these fungible issue tokens. They aren't Satoshis. Could be dollars or something. Gosh, I mean, what a thought. Represent dollars. So my balance minus send amount equals 0. We add change. Now we've built our outputs. So we got inputs and we got outputs. That's what you need to make a Bitcoin transaction, right? Or in this case, a tokenization transaction. Create the transaction. Okay. And should we include the sender, the recipient public key in the send to something like there we go. Send the transaction to the overlay. So after we got the transaction created, we should send it to the overlay, right? So that's the scary part. Because if I send this to the overlay, then it's going to be registered. And then I can't undo it easily. So I kind of want to not do that yet. And I also kind of want to not create the transaction yet. I want to test this. So I want to comment this out. I want to comment this out. and I want to put a debugger statement right here so that nothing happens. So it's going to go and compute all this stuff, and then nothing's going to happen. It'll just open a debugger. Save this, and let's see about trying to send a transaction that has this behavior in it. We can sanity check at least a little bit. Okay, this looks to be loaded properly. I'm going to send 33 tokens to this sender, or to this recipient, which is me. Say sending that, we say okay, and what happens? Well, got an error. Must provide an amount for the output. Oh, good point. Must provide an amount for the output. That is going to be in unlocking script, push drop.redeem, const t of my tokens t dot. Okay, so I should look at my tokens then, or t. Otherwise, I'll just open up the debugger again. I want to send 33 tokens to that. So I have an amount. So it's amount, an envelope, output script, spendable, txidv out. So it's amount in this case. So output amount is amount. txidv out output script. It's going to be t dot envelope, I think. T dot envelope dot inputs. All right. Saving that. Let's see how it does now. It's just now loading. Sending 33 tokens to this address in theory. Not actually yet, but okay, it's asking to access the tokens with this new counterparty to drive the output, which makes sense. And now I see my debugger. So what's in the outputs array? There are two outputs. That is as expected, each with a script and a number of satoshis. These are token outputs. And then the inputs, where do those come in from? So there's going to be one, right? There's the outputs to redeem, the proof, the raw TX, and this is going to be unlocking script. That is the correct unlocking script, it looks like. So that means we're redeeming one input and creating two outputs, one of which is change and one of which is the actual amount we're sending. And that means we're pretty close to being able to send this. That's kind of what we wanted. So we've done that much. And now I'm looking at this amount, envelope, output script, TXID, and vout. So that got logged. So each of the my tokens variables has an amount, right? Envelope, output script, TXID, vout. I'm going to open up that text edit document we started with again and write that down because I want to make sure we have that format properly. So token transport format, amount, TXID, vout, output script, and envelope. So that's what we need to construct for each of the parties, for each of the outputs that we are creating. So we create the transaction, send the transaction to the overlay, send the transaction to the recipient, update our own tokens for the new outputs. So token for recipient equals, and we're going to pretend like action exists. We have action.txid. Okay, vout I know is 0 because it was the first output that we added for them. Amount we know is 1,000. Satoshi amount is always 1,000 in this case. Envelope is just ... action. And there's one other thing, which is output script. And that is the value of recipient script. Okay. And this one, change script, needs to be pulled out. Okay. And then that's a valid, that should be anyways, a valid token to send to the recipient via a PeerServe message. And we have code for that. Send the transaction to the recipient, right? So token should be token for recipient. So not actually enabling this code yet because I'm scared, but that'll be there when we do. And finally, the whole update your own tokens. Okay, so if a change script was defined, then we want to essentially create a new one of these. Only it's vout1 and change script. So vout1 and change script. And this is token for change. Let's just say my new tokens equals an empty array, and something like my new tokens dot push token for change if that happens, and then it would be something like set my tokens, my new tokens, and then it would also be something like await set my tokens JSON.stringify my new tokens. And that one I want to put actually above that. Okay. So if that happens, we do that. If that happens, we do that. That's the code for create action. So I want to mock this out one last time. Pretending this is a thing, we know we have txid, foo, raw tx, ... Okay. So that's a pretend. Debugger, come down a little further to the bottom. So send the transaction to the overlay, skip, and that's going to be last time we skipped that as well. Send the transaction to the recipient. That's commented out. This is also going to be commented out. Okay. So I'm getting more confident in this a little bit, which is just thinking through here. So we're not actually creating the transaction yet. We're not sending anything to anyone yet, but I do want the code to be able to uncomment at the end here for sending to the overlay. That's not hard. It's just going to be something like send, maybe await. Something like that. Send to overlay. Is that the function up here? Submit to overlay and you take in the action. Okay. All right. Last dry run. Before we actually send this, before we make the first token transfer. Okay, so I'll refresh this. And we'll go ahead and say, 33 tokens is being sent to this maniac. Send. Okay. I should see a debugger, right? Did I put the debugger in? Oh no. My new tokens. All right, so it arrived at a new state. I did not put a debugger in. But I do see that I have my new tokens, which has a txid, right? That's fine. Amount, output script, it would have created, and that's it. v-out1 because it's change. Okay, I think this has as good a chance as any of working. So I'm gonna plug it all in. Action is await SDK create action with the inputs and the output. So it's just going to be called create action. With the inputs and outputs, we'll get rid of this pretend code here. We'll submit it to the overlay. We'll send it to the recipient, and then we'll update our own tokens. So, whoops, send the transaction to the recipient. JSON.stringify token, token for recipient, which makes sense. set up my new tokens, and we call set. And then we call set locally. All right, this is now all plugged in. And we'll go ahead and save it and just see what happens. If we mess up the entire overlay network because we consume the UTXO without creating a viable candidate for an update that is accepted by the topic, well, YOLO. We'll figure it out. 33 tokens will be transferred to this person. And I'll do that, and I'll hit OK. Off it goes. So it's asking me to create a transaction which has plus 1,000 minus, yeah, that looks right. I'll allow the transaction. Now it's submitting. And it's asking me to create a new transaction to actually update the my tokens variable, I believe. It's the last set. And submit was called. Looks to be unsuccessfully. Was that for KV store? Payload, topics, KV store. Interesting. Okay. I don't think that's relevant. Okay, so I see that my balance is 1,033. I see that I have 1,000 in my tokens because the balance didn't update when the one updated. Let's inspect all of the. So the network is going to tell the story, right? Basically, all this stuff happened. List messages. Okay, initial request, lookup. Okay, create action. The create action call had inputs and outputs, send 33 tokens to that key. That looks to be correct. That was accepted. Then it went and called submit, submitting this to the overlay network. This is key. The tie points and the response was that it did not admit any of the outputs into the overlay. No, none of these outputs were admitted into the overlay from that transaction. Then it went to send a message to the recipient, right? And that message contained the body, which was the token, which contained the TXID, among other things. Then went to look up the KV store value, I think. And it went to set the KV store value for my tokens. And that did not succeed. And why that didn't succeed, okay. It looks like there was an input script verification error on the SPV envelope for setting the KV store value. However, I don't think that's relevant to the, I mean, that should be resolved, but that's not relevant to the actual things that are going on here. What I'd like to know is why this did not admit, why that did not admit the new tokens into the overlay. So before doing anything else, I'm going to access the logs again and just see what I can find within the overlay network itself to indicate as to potentially what may have transpired when that transaction was submitted. Because that transaction was successfully created, which effectuated that transfer. But the overlay, for some reason, did not accept the transaction. So just give me a moment to review some information. Okay. So that was the KV store one. That's did not succeed. However, before that, there was the and that was the lookup for that one. I'm just traversing some logs here. I believe I'm now reading the transaction that is relevant. Okay, incoming submit and admissible outputs empty. I see. So let me just copy this error so that I can show it to you guys. So I'm just going to I'm going to give you the relevant part of the error here and bring it back onto the screen. So upon reviewing the logs, I found this when the transaction was submitted, the relevant transaction. So if I go to the this screen here and I see, right, send 33 tokens to that, this TXID here, the one that is the important one, I get this issue in relevant part. This isn't the entire stack trace, but So it's saying unable to read properties of undefined reading match at object.module.exports as decode. So push_drop.decode basically. On line 22. So if I go and check what push_drop.decode on line 22 is, we can attempt to see more insight into that. Script.match hex characters equals null. Then right. So if it cannot read properties of undefined reading match, means that script was not provided in push_drop.decode. Okay. And the token manager identify admissible outputs. Line 54 is where that was called. So let's go look at line 54 of the topic manager and see what relevant thing we can find. Token payload is push_drop.decode. And that is utxo.output script. And that is from previous UTXOs. So it is essentially an issue with looking at previous UTXOs. So what is the format provided? What is the format of previous UTXOs when they are provided to the topic manager? Because there were previous UTXOs, they just had an issue, it looks like. So a couple things. Firstly, I'll log the UTXO itself. And secondly, I'm going to go look at the format to ensure that according to my internal implementation of the system, things are working properly. Previous UTXOs. I'm just running through some internal code here to try to identify here what the reason is behind this not working entirely as it should. So I'm just looking at some of the internal implementation here to figure out an internal issue that should not have propagated. This far. Almost finished with identifying the root of the issue. Yes. Okay. I have identified the root cause of the issue, and I'm now going to implement what I believe to be the fix. All right. The source of the issue has been identified, I believe. And so essentially when we wrote the topic manager in the last stream, we were going through this list of previous UTXOs and sending the script into the decoder. However, it was missing this two-string hex because when scripts are provided in previous UTXOs to a topic manager, they are given as a buffer, and they need to be given as a hex string to push drop.decode. So by adding this two-string hex, we should be able to resolve the issue. Fix decode of previous UTXOs. That's going to make the version number 0.1.3. All right. So that's published onto NPM. And I will now go ahead and deploy that same thing to the production. Overlay network node here. Okay, we're just now deploying the new version here. All right, so I'm realizing that as I deploy this new version, I'm not going to be able to, I'm going to need to reissue the overlay network because of the fact that the new UTXOs were not admitted into the topic. And I can't admit to them if they're based on, so I need to get a new issuance TXID essentially and reconfigure for that so that once the sort of so that I can enable the sort of I need to get a new issuance TXID so that when I submit a new UTXO to the overlay, there will be something there to receive and deal with. Currently, I don't have any UTXOs that I can use on the overlay because that new transaction created UTXOs that are currently seen as valid according to Bitcoin, but not valid according to the wait. Let's think. Can I submit the existing transaction again? I may not need to create a new issuance for the overlay if I can get the existing transaction to be recognized as valid on the new one. So if I can manage that, that would be ideal. Let me try to essentially finagle the database into believing that I am allowed to resubmit that transaction that we made that sent 33 tokens. And if I can manage that, we need to do less work here. So all right, I think I can, well, okay, good. I think I can bring my screen back up here. What I'm doing now is I'm trying to get the overlay network to accept the transaction that it previously would not accept. So we have this function up here called submit to overlay. I'm gonna window.s equals submit to overlay. Okay, and that way when the page loads, I can essentially, right, I don't know what my balance is going to, it's probably gonna be 0 at the end. But oh, am I precluded from, let's see. Let's see. I just want to access my console here, and it wasn't letting me click on anything. So let's see, console. Token is for me, but not on the overlay. So right now it says that I have 1033, and it says I have that one token, and it's trying to receive and process an incoming token, but it's not allowing that to happen. But if I say await s, and I can pass in a value here, and I can grab the tx envelope, which I have this pulled up from HashWrap, and submit that envelope to that overlay and get it to accept it, then I may be in a position to get that onto the overlay. So submit 400. And it's giving me SPV errors. I don't have, let's see. Expected Merkle root is not matching the computed Merkle root, indicating that perhaps there's an error of some kind. I need to update an internal package to try to rectify that. If I can manage. Right now what I'm trying to do is obtain a valid transaction envelope for that transaction so that I might be able to submit it to the overlay network. In order to obtain that envelope, I need to update an internal tool which facilitates access to envelopes. And that tool had not been updated for 9 months. Just waiting for the update to propagate to the internal tool so that I can access correctly formatted BRC8 transaction envelopes as required to submit these types of transactions to the overlay. Let's sync here. So the deployment process for the internal tool should be largely complete. And I will now be able to hopefully use this. So this tool is called HashWrap, and it is how to obtain a BRC8 transaction envelope for a Bitcoin transaction. And I am now clear to put my screen back up. All right. I will try to use the new version of this to obtain a correct transaction envelope. And then I will attempt to submit said transaction envelope to the overlay. And the topics are the type points topic, which has no admissible outputs. So the transaction was once again attempted to be submitted onto the overlay, but it did not have any outputs that were seen as admissible, despite the changes that I've made. So therefore, I will check the logs. And acting on some information that I've received from the logs, I will continue to debug. So the logs are indicating that, and I can try to put up the screen here in just a second. Right. So the logs are indicating that, right, I submitted this transaction, it accepted it. Logs are indicating that the maximum tokens allowed were 0. So what this indicates to me is that we're going through this set of UTXOs, trying to admit things into the topic, etc. And I believe the UTXOs may have already been removed from the last time, even though that new transaction is being submitted. So I think that what I need to do is reseed the overlay network using a new issuance transaction. And that way, when I go and deploy it again, we'll be ready to test everything with that new issuance transaction. So what I'm going to do is just reconfigure. Well, first I'll create a new issuance transaction using the code we have in here for that purpose, the mint section here at the top. So I have this handle mint function. We're creating a token script with a token amount that we're minting. And then we're saying transaction, and we essentially just log the transaction. We're not doing anything with it. I'm not going to insert it into this basket any longer. I don't think that's necessary. So essentially what I'd want to do is mint the token, right? And then I want to send it to myself so that the next time I reload the page, I would be able to. So I'm gonna do a couple things. I have S, so we submit, right? I can submit to overlay. It's going to be here. Set is going to be set as well. I'm going to call that KV set because I don't know if there's actually a thing on window called set. Okay, so KV set. Actually, I want to remove as well. I want to import remove. I'm just thinking ahead here, so bear with me. So when I mint this, right, I want to send the new token to myself so that and I'll handle submitting manually to the overlay because I have to submit it afterwards. But essentially this code here, I want to put into the mint function so that after a token gets minted, I'm sending it to myself, because I am in fact the owner at that point of that token, and I want to be able to do that so that this is called transaction. This is called token script. I'm sending it to my own identity key. I'm setting this message, and it is that I'm sending. So when that happens, and the other thing I want to do in this case is actually set, actually it's remove my tokens. And that way, when I go and do this later, I will be in a position to have no tokens. So, right. Let's go ahead and create a new issuance transaction with this system. So this is going to be some invalid, right? Okay, that's all. All the previous things are gone. Okay. I want to issue, and this time I'll issue 3301 tokens under type points. So there's the transaction, and I believe that is what you can expect. So the TXID of this transaction is going to be here. That is the new issuance transaction. I will now go and grab the, well, I have that in a second. Maybe it gets confirmed. I will now go and deploy the overlay network again internally with the new issuance TXID, and I will then wipe out the lookup service so that when I access it in the future, there will be no existing tokens. And I think that's what was necessary to facilitate the workings of the network. So there were no tokens in the lookup service anyways, so that was not necessary. And now I'm going to just go ahead and deploy with the new issuance TXID. And once that happens, it'll be a simple matter of submitting the new issuance TXID, reloading the page, so I'm putting the new issuance TXID into the system. Pushing that up to production. And now that is deploying. So the new issuance TXID is currently been updated, and I'll just grab an envelope for the new one. And I'll then, get ready to send this once the deployment process succeeds. And I will also now monitor said deployment process. And once the deployment process succeeds, I'll be able to put the new issuance in place. That should add a new one to the topic manager, and it should kind of reset everything, or into the lookup service as well. And it should kind of reset everything so that any previous bugs that had happened with topic admittance would be resolved, and the UTXO would be sort of retained, at least within the current context. So the deployment process is on the final step. And the deployment process should now be completed. Okay, so the new issuance TXID has been configured within the context of the overlay topic that we're working with. I'll now enable my screen again. So I've obtained this SPV envelope for the transaction. Let's see if a new one, if it's got confirmed yet. Nope, not yet. So I've got that envelope over here. Now that the deployment has completed, I'm ready to submit the issuance transaction to the overlay. Which should emit the first output into the relevant topic if I've done everything properly. And this indicates that we have the first topic is now in the overlay and in the lookup service. And if I've done everything properly, right, because I sent that message to myself, when I refresh this page, I should see 3,301 tokens in my tokens, as well as have everything available. So let's see. So I have belongs, it is on the overlay, do not have this token yet. I'm now receiving a request to update my state. I'm proceeding with the state update. I'm checking. The create action call is still pending. Do I have anything in the metadata? Oh, I didn't approve it or something? I don't understand. Why is that network request still pending? I've approved it. The create action call is still, in fact, pending. Which is, of course, problematic. Checking logs. Nothing significant discovered in the logs. So this is crucial because it's setting the my tokens variable. And if it doesn't do that, then I won't be able to access the token. However, if that create action call is still pending and it hasn't actually set it, then it also hasn't acknowledged the message yet. So I'm going to refresh the page in the hopes that it'll simply rerun that process until the peer serve message is acknowledged, hopefully. Okay, I'm going to approve the action once more. And check the network tab. And once again, we see the create action call is still, still pending. So this create action call with one input and one output being the KV store related call simply is pending. And that is, of course, not acceptable. Now, of course, I've done this. I'm going to try to remove KV if I can manage that. I believe that my MetaNet client needs to be restarted forcefully. Okay, so I want to restart the MetaNet client. I don't know what the cause of that is. However, I expect the stability of such processes to improve with time. The create action call is still pending, which makes it so that I cannot easily access my my tokens. I'm going to see what the current state of this variable is. Of course, it's going to try to process the message each time. And each time it will be pending. So for some strange reason, calling create action with those parameters is leading to an issue with the MetaNet client. I wonder what is the current state of this variable. Rather than to use the myTokens variable within this context as a temporary fix to this and pending investigation from the internal team, I'm going to change this to be whoever used tie tokens instead of myTokens. And then going to reload the page and attempt to process the incoming token using a new key, which may yield different results. And there we are. The token has been saved properly. And the balance is 3301, and the myTokens, I have one, which is 3301. That is correct. Refreshing the page, I will, before doing this, I'll verify that it is working properly by saying kv get tie tokens. Oh, I gotta await, of course, just to make sure that it's here. And yes, it is. So that is the token, right? I can now refresh the page. I will not see the KV, I will not see the incoming messaging logic, the incoming token processing logic run any longer, and I will still see my token balance of 3,301 tokens. So now we're to a point where the overlay network has synchronized state. The bug has been resolved with the one where it wasn't allowing the processing of the second transaction. And now let's attempt to send once again a token, or 10 tokens rather. We'll change it to 1,033 tokens. And we'll send it on the overlay. Here goes. So let's observe what has happened here. First, we listed our incoming messages, and we called lookup. And this is going to be a lookup for, I think, KV store. Called create action with one input and two outputs. And then we called submit. And this time we saw tie points did not admit any of the UTXOs. So no UTXOs admitted, I don't believe. We then sent a message to the recipient containing the token that we wanted to send them. We then ran a lookup on KV store. And just like last time, we tried to add a new thing to KV store, but when the KV store input was attempted to be added, or when the value was attempted to be updated, the update did not succeed. And the reason for that is going to be likely relating to an input script invalidity. For input 0 of the transaction was invalid. It did not execute properly. Okay. So now I'll consult the logs once more. I think I'll end the stream soon, just because I've been on for a while. But I'll consult the logs once more to see why the UTXOs were not admitted this time. And so I see the KV store one, and previous to that, I see some lookups for KV store. Previous to that, I'm looking for the submit, which is to type points, where I can then see what the error might be. So I see that. And I see a clean set of logs with no admissible outputs. Console.llg is not a function. On line 54 of the manager. Of course. So I'll bring up the screen again to indicate what I've just changed. So I typed console.llg in a very crucial place, and for that reason the code did not succeed, no outputs were admitted, and we need to reissue the overlay network once more. So I think I'll do that next time. We are getting very close to having tokenization work properly, and I'm very happy with this progress. I mean, we have the logic here pretty much down, and it's just a matter of debugging. So next time I think we'll plan on kind of getting the transfer to work between a single user. Maybe I'll arrange to have somebody come on stream to test multi-user functionality, and then we'll clean up some of the code and really round out the functionality that we're building here, which is single issuance, fungible tokens, usable for general purpose, usable for essentially general purpose use cases on top of a Bitcoin overlay network. So I fixed this typo. I'll I'll stop here, and when I'm ready to continue, I will start streaming again to finish this up and get everything where it needs to be. So this has been a stream to document more than anything the process of getting tokenization to work using this model for Bitcoin and the scalable UTXO architecture. Thank you for tuning in, and I'll catch you in the next one.